Good day everyone, welcome to Let Me Engineer You. Today, we will discuss the Manual for Professional Practice of Civil Engineers, focusing on the ethical principles, laws, and professional guidelines that govern civil engineering practice in the Philippines. As future engineers, it is not enough to know how to design structures, calculate loads, or manage construction projects. You must also understand your legal responsibilities, ethical duties, and professional obligations. Engineering decisions directly affect public safety, the environment, and society, which is why engineers are considered professionals with high moral and legal accountability. Next slide. Civil engineers are expected to uphold integrity, honor, and dignity in their profession. This means using engineering knowledge to enhance human welfare and protect the environment. For example, designing earthquake-resistant buildings, flood control systems, and safe transportation systems directly improves public safety and quality of life. Engineers must also be honest and impartial, meaning we should not favor personal interests over public welfare. We must also continuously improve our competence because technology, standards, and codes are constantly evolving. Lastly, engineers should support professional organizations, such as the Philippine Institute of Civil Engineers or PICE, which promote ethical practice and professional development. Next slide. The PICE Code of Ethics is the moral foundation of civil engineering practice. First, public welfare. Engineers must prioritize the safety, health, and welfare of the public. For instance, an engineer should not approve a structurally unsafe design just to reduce cost. Second, professional integrity. Engineers must be honest, fair, and impartial. This includes avoiding bribery, falsification of documents, and misrepresentation of qualifications. Third, responsibility. Engineers must accept accountability for their designs and decisions. If a structure fails due to negligence, the engineer can be legally and ethically liable. Fourth, competence. Engineers should only undertake projects they are qualified to handle and should continuously update their knowledge. Next slide. Another principle is sustainability. Civil engineers must design structures that are environmentally sound and resource efficient. Confidentiality means engineers must respect sensitive information about clients and projects. Collegiality means treating colleagues, workers, and stakeholders with respect, avoiding unfair criticism or unethical competition. Next slide. Now let's discuss some of the basic engineering laws here in the Philippines. Let us begin with the Republic Act No. 544, Civil Engineering Law. Republic Act No. 544 is the primary law regulating civil engineering practice in the Philippines. It defines what constitutes civil engineering practice and who is allowed to practice. It established the Board of Civil Engineering under the PRC, which administers licensure exams and regulates the profession. Practicing civil engineering without a license is illegal and punishable by law to protect public safety. Next slide. Republic Act No. 1582, Amendment to RA 544. Republic Act No. 1582 expanded and clarified civil engineering practice. It strengthened licensing requirements and clarified professional responsibilities and ethical standards. Next slide. Qualifications for licensure. To take the Civil Engineering Board examination, an applicant must be at least 21 years old, be of good moral character, hold a BSce degree from a recognized institution, not be convicted of crimes involving moral turpitude, be a Filipino citizen or foreign national with reciprocity. These requirements ensure that only qualified and ethical individuals enter the profession. Next slide. PRC registration and license renewal. Passing the board exam is not the end. Engineers must register with the PRC to obtain their professional identification card and certificate of registration. Licenses must be renewed every 3 years, and engineers must complete continuing professional development or CPD units under RA 10912. Next slide. In summary of RA 1582, engineers must 1. Pass the licensure exam. 2. Register with PRC. 3. Renew licenses every 3 years. 4. Use a professional seal on plans. 5. Avoid fraudulent practice. 6. Follow the PICE Code of Ethics. 7. Accept penalties for violations. This ensures professionalism and accountability. Next slide. Republic Act No. 9266, Architecture Law. RA 9266 defines the roles of architects and civil engineers. Architects handle architectural and aesthetic design, while civil engineers are responsible for structural and engineering systems. This law clarifies professional boundaries to avoid conflicts and ensure proper responsibility. Next slide. Republic Act No. 10912, CPD Act. The Continuing Professional Development Act requires engineers to earn CPD units. This ensures engineers stay updated with new technologies, codes, and engineering practices. Engineering is a dynamic field, and outdated knowledge can lead to unsafe designs. Next slide. National Building Code, PD 1096, RA 6541, which we just discussed lately in previous sessions. As a recall, the National Building Code regulates building design, construction standards, and permitting. Civil engineers must ensure structural integrity, safety, and compliance before construction permits are approved. Next slide. Presidential Decree No. 223, Creation of PRC. PD 223 created the Professional Regulation Commission, which governs licensure, discipline, and enforcement of professional standards. The PRC ensures the observance of the Professional Code of Ethics, which is not limited to civil engineers but also licensed professionals. PRC can suspend or revoke licenses for unethical or illegal practice. Next slide. Republic Act No. 9184, Government Procurement Reform Act. This law governs public infrastructure projects. It requires transparent bidding processes to prevent corruption and ensure fair competition among contractors and consultants. We will have a detailed discussion of this one on a later session. Next slide. Presidential Decree No. 498, Professional Tax. Civil engineers engaged in private practice must pay an annual professional tax. This is a legal obligation similar to other licensed professionals. Next slide. Batas Pambansa Bilang, Tadlong Dan at Apit Napud Apit, the Accessibility Law. BP 344 ensures buildings and infrastructure are accessible to persons with disabilities. Civil engineers must design ramps, handrails, and accessible facilities for inclusive design. Next slide. Environmental laws affecting civil engineering. Engineers must comply with environmental laws such as Climate Change Act, Clean Water Act, Clean Air Act, Ecological Solid Waste Management Act. These laws require sustainable and environmentally responsible engineering practices. Next slide. Professional guidelines. In addition to laws, engineers must follow the PICE Professional Guide and Standards of Professional Practice. These guidelines define ethical conduct, responsibilities, and professional fees. Next slide. PICE Code of Ethics, Responsibility to the Public. Engineers must prioritize public safety, avoid misleading statements, and report unsafe practices. Public welfare must always be the top priority. Next slide. Professional integrity and honesty. Engineers must avoid fraud, falsification, and conflicts of interest. They must only sign plans they prepared or reviewed personally. Next slide. Competence and continuous learning. Engineers must work only within their expertise and continuously improve through seminars, CPD, and professional training. Next slide. Fairness and respect for colleagues. Engineers must treat colleagues fairly, avoid unethical competition, and contribute to the profession. Next slide. Sustainability and environmental responsibility. Engineers must design environmentally sustainable and disaster-resilient structures and comply with environmental laws. Next slide. Compliance with laws and regulations. Engineers must follow all laws, avoid corruption, honor contracts, and comply with professional standards. Next slide. Scope of civil engineering practice. Civil engineering is a broad profession that covers many specialized fields. The PICE Professional Guide and Philippine laws define the scope of practice to ensure that civil engineers work within their legal and technical responsibilities. 1. Structural engineering. Structural engineering involves the analysis and design of structures such as buildings, bridges, towers, dams, and other load-bearing systems. 2. Geotechnical engineering. Geotechnical engineering deals with soil and foundation engineering. Civil engineers analyze soil properties to design foundations, retaining walls, slopes and embankments, ground improvement systems. This field is crucial because many structural failures occur due to foundation problems, not structural design errors. 3. Transportation and traffic engineering. Transportation engineering focuses on the planning, design, and operation of transportation systems such as highways and roads, railways, airports, ports and harbors. Traffic engineering involves traffic flow analysis, signal design, and safety studies to reduce congestion and accidents. 4. Water resources and environmental engineering. Water resources engineering includes hydrology and flood control, irrigation systems, water supply systems, drainage and sewerage systems. Environmental engineering involves pollution control, wastewater treatment, solid waste management, and environmental impact assessment. 5. Construction engineering and project management. Construction engineering focuses on how projects are built, including construction methods, scheduling and planning, cost control and budgeting, quality assurance and safety. Project managers coordinate engineers, contractors, suppliers, and stakeholders to ensure projects are completed on time, within budget, and according to specifications. 6. Consulting and specialized services. Civil engineers may also provide feasibility studies, expert witness testimony, structural audits, value engineering, technical consulting. These services require high expertise and professional responsibility. Next slide. Cost of civil engineering services. Civil engineers are professionals, and like doctors and lawyers, they are entitled to professional fees for their services. The PICE Professional Guide outlines different methods of charging fees. 1. Percentage-based fee. This is the most common method for large projects. The engineer charges a percentage of the total construction cost. Typical ranges. If structural design only, rate ranges from 1% to 5% of project cost. If project management is included, rate expanded from 5% to 15% of project cost. For example, if a building costs 5 million pesos and the structural design fee is 2%, your fee will be 0.02 of 5 million, that will be 100,000 pesos. Sounds profitable for a single project, right? This method is commonly used in building and infrastructure projects. 2. Lump sum fee. A lump sum fee is a fixed amount agreed upon before the project starts. This is commonly used for feasibility studies, consulting services, small projects, structural assessments. For example, a civil engineer may charge 100,000 pesos for a structural assessment report regardless of project size. That's a huge amount. However, fixed amount must be at reasonable considering the factors such as complexity, scope of work, project size, your expertise, and more. You can apply discount if your client asks for it, but should be at competent level where you will not bargain too much just only to acquire clients and may deprive others. That's very unethical. Next. 3. Hourly or daily rate. This method is used for site supervision, consultation, short-term technical services. Your typical rates range from 1,500 pesos to 5,000 pesos per hour or higher for experienced engineers. For example, if an engineer charges 2,000 pesos per hour for just 3 hours of site inspection, then you will have 6,000 pesos in total for just that short period. Next. 4. Unit rate fee. This method is common for design services. The fee is based on the floor area or project quantity. Typical rates: 50 pesos to 500 pesos per square meter, depending on complexity. For example, for a 100 square meters floor area of a building at 200 pesos per m squared, your fee will be 100 times 200 equals 20,000 pesos. So, why professional fees matter? Professional fees ensure: 1. Engineers are compensated fairly. 2. Quality design and supervision. 3. Ethical practice. Undercutting fees may lead to poor quality engineering and unsafe structures. Next. Factors affecting professional fees. Professional fees are not fixed, they depend on several factors. 1. Project complexity. For simple projects, such as single-story residential buildings and small warehouses, ranges between 1% to 2%. For moderately complex projects, such as multi-story buildings and bridges, ranges between 2% to 4%. For highly complex projects, such as dams, high-rise buildings, and industrial plants, ranges from 4% to 5% or more. Complex projects require advanced analysis and greater responsibility. Next is 2. Scope of work. A full service, which includes design, supervision, and project management, may require higher fees in total. These include percentage-based fees and hourly or daily rate fees, while partial service is design only or consultation only, which only requires lower fees because of a single task service only. The more responsibilities the engineer has, the higher the professional fee. 3. Project size or construction cost. Small projects may have higher percentage fees because fixed costs are the same. Large projects may have lower percentage fees due to economies of scale. 4. Engineers' expertise and experience. Newly licensed engineers can be paid with lower fees because of a lack of experience. Senior engineers and experts can be paid higher fees because of their track record, experience, and reputation. Experience reduces risk and increases reliability, which clients are willing to pay for. 5. Location of the project. In urban areas, it requires higher fees due to higher cost of living, more complex regulations, higher labor and material costs. While in rural areas, it requires lower base fees but additional costs for travel, accommodation, and logistics. 6. Timeline or urgency. Urgent projects require overtime, additional manpower, and fast-track analysis. Higher fees are justified. 7. Type of client or funding source. Private clients may often be willing to pay higher professional fees. In government projects, fees may be limited due to budget and procurement laws, often through competitive bidding. 8. Environmental and safety requirements. If projects requiring environmental impact assessment, disaster-resilient design, and safety audits, these require more work, documentation, and responsibility, which results in higher additional fees. Next. Responsibilities of civil engineers. Civil engineers can work in different professional roles. Each role has distinct legal, technical, and ethical responsibilities. 1. Consulting engineer. A consulting engineer provides professional advice and technical expertise to clients, government agencies, or private companies. Key responsibilities. Conduct feasibility studies. Prepare engineering designs and plans. Review and approve technical documents. Provide expert opinions and recommendations. Serve as expert witness in court cases. Example. A consulting engineer may evaluate whether a bridge design is safe or recommend improvements in a flood control system. 2. Contractor, site engineer. A contractor or site engineer is responsible for actual construction implementation. Key responsibilities. Supervise construction activities. Ensure compliance with plans, specifications, and codes. Manage construction workers and equipment. Implement quality control and safety procedures. Report progress and issues to the project manager. Example. A site engineer ensures that concrete strength meets design requirements and that structural members are built according to drawings. 3. Project manager. The project manager oversees the overall project execution. Key responsibilities. Planning and scheduling. Budgeting and cost control. Coordination among engineers, contractors, suppliers, and clients. Risk management and decision-making. Ensuring project completion on time and within budget. Example. A project manager ensures that a building project does not exceed the budget and is completed before the deadline. 4. Government engineer. Government engineers work in agencies such as DPWH, LGUs, MWSS, DENR, and other regulatory bodies. Key responsibilities. Review and approve engineering plans and permits. Inspect public infrastructure projects. Ensure compliance with laws and standards. Implement government infrastructure programs. Protect public interest in public works. Example. A government engineer checks if a building design complies with the National Building Code before issuing a permit. Professional accountability across all roles. Regardless of role, civil engineers must prioritize public safety. Follow engineering laws and codes. Act ethically and honestly. Maintain competence. Accept responsibility for their decisions. Civil engineers can be administratively, civilly, and criminally liable for negligence or unethical practice. Next. Standard contracts and ethical compensation. Formal contracts and ethical compensation practices must govern professional engineering services. 1. Importance of written contracts. A written contract is a legal agreement between the engineer and the client. Contracts usually define A. Scope of services. B. Professional fees and payment terms. C. Responsibilities and liabilities. D. Project timeline. E. Dispute resolution terms. Why contracts are important. It protects both the engineer and the client, prevents misunderstandings, provides legal evidence in disputes, and ensures clear expectations. 2. Ethical compensation of engineers. Civil engineers must be fairly compensated for their professional services. The PICE Professional Guide discourages undercutting professional fees, which is considered unethical. Why undercutting is unethical? Devalues the profession. Encourages poor quality engineering work. Compromises public safety. Promotes unfair competition. 3. Avoiding conflict of interest. Engineers must avoid situations where personal interests conflict with professional duties. Examples. Accepting bribes to approve unsafe designs, recommending contractors for personal gain, and designing projects where the engineer has a financial interest without disclosure. These examples are illegal based on the Professional Code of Ethics. 4. Refusing unethical or illegal projects. Engineers must refuse projects that violate laws and building codes, involve corruption or bribery, endanger public safety, and require falsification of documents. For example, if a client asks an engineer to reduce structural safety to save cost, the engineer must refuse and report the situation. 5. Professional liability and accountability. Civil engineers are legally responsible for their work. Possible liabilities. Civil liability, which leads to damages and compensation. Administrative sanctions, which can lead to license suspension or revocation. Criminal liability if there's negligence that causes death or serious harm. 6. Ethical practice in contracts and compensation. Ethical practice includes transparent billing, honest reporting of work, respecting contractual obligations, and avoiding fraudulent claims. Engineers must ensure that professional practice is transparent, fair, and lawful. These principles ensure that civil engineers maintain public trust and protect the safety and welfare of society. The following slide is an example of a written contract which specifies and defines the. And this concludes the presentation. Thank you for listening. If you like the video, hit like and subscribe for more videos. Have a good day.